going to go for 26 and 27. 26, I've got already graphed here. Um, so I'm trying to figure out how they were going to solve this thing and come up with what the heck they're talking about here. And so my first instinct was, oh, I'll graph it because they want me to find a point that lies on the graph of each equation in this plane. Um, and so when I graphed it to see, I was hoping they'd intersect at one point and I just find the point where they cross. But when I graphed it, I found out they're the exact same line. Okay, and I should have noticed that right away because this second equation, if I divide everybody by 5, it becomes that first equation. So these are the same two equations. So if any of these points lie on this purple one, the first one, then they're also going to lie on that one because they're the same line. Okay, so we just got to see which one of these points uh, makes this equation true. And so we're going to have to plug this in for x, plug this in for y, and see if we get a 7. Now that didn't seem like it's going to be too bad, so let's try it out here. I'll first plug in the point A. I'll go, well, that'd be 2, because that's the purple. Here comes what the x value is. R over 5 plus 7. And then close my parentheses. Then I got plus 3, and I have to put in my y value. But my y value, I'll circle him in green, is negative r over 5 plus 35. And the question is that a solution? Does that make this equation true? Does it make it equal a 7? So let's see here. We'll do a little math. Distribute. That's 2r over 5 plus 14 minus, because I'm going to get this negative 3r. So let's do plus a negative 3r over 5. And 3 times 35 is 105. I don't see how this is going to work out to give you a 7 at all because these two are not equal and opposites. It's going to be like negative 1r over 5. These two equal 119. And this just does not equal 7. Okay. Um, I could still multiply by both sides by 5 just to see if the thing would make it true, but it's just not going to. We're going to get something else. So we're not getting a 7 there, so that didn't work. So let's try another ordered pair. Let's try B. Oh, by the way, I guess I know it's not this one because if I put an R in here, that's 2R. And well, maybe it could be that guy, so I can't rule them out yet. So let me just try this second point. So it'll be now 2. So I'm using my first equation again. My x this time is negative 3r over 2 plus 7 over 2. So that was my x. My y in this case is just r. So plus 3 r's. As my formula says 3 times y, and y is r. And we'll see if that equals 7. Question mark. Okay, so I'm just working on the left side here. So I distribute my 2, I get negative 3r, the 2's cancel. I distribute my 2, the 2's cancel, I get 7. Plus 3r. Negative 3r, pop, there we go, 7 equals 7. So this point is on there. Whew. That's pretty tough to figure out. I'm trying to think if there's another way you could do it. Um, and I did, I when I thought about it the first time, I think what I did is I took this 2x plus 3y, the original equation, and I solved it for y, thinking it was just going to be either c or d down here, and I'll show you why. I go 3y, I subtract my 2x, I get y equals negative 2/3 x plus 7/3. I divided everybody by that 3 right there. And I said, well, if it's this one, I just plug it in r, and the y value would be negative 2 times r thirds, so negative 2/3 r plus 7/3. I looked at this one and it's not negative 2/3, it's positive 2/3. So that didn't work. And if I plug the R in from here, it should give me this. So I plug in R and I get negative 2/3 R, but it's supposed to be negative 3R over 2. So it's not matching there. So I knew it wasn't C or D. And that got me, it had to be those two. Um, so there's other workarounds for it, and ask me if you have another idea on how to figure out that it's B. All right, last question, 27. So the perimeter of an equilateral triangle. So equilateral means equal sides. You know, everybody's had geometry, so everybody should know that. Has a perimeter 624. So that's the sum of its sides. So all the sides are equal. That's equilateral. There's three sides, so I'm going to divide this by 3. 2, 0, 8. 208. So each side is 208 centimeters long. They all add up now to that 624. And the height of the triangle, the height is always measured perpendicular to one of your vertices. So, or not perpendicular to it, but from one of your vertices perpendicular to the opposite side. So there's a height, and that height is k root 3's. Okay, so there's a couple ways to solve this problem. Okay, and what we're going to do is we will just focus on just one of these triangles. I'll highlight them in yellow here. I'm just going to focus on that one. And I'll zoom in here a little bit so we can really see what's going on. All right. So in this triangle, it's equilateral, so it's also equal angular. So I know this is 60 degrees. I know this one is 60 degrees. And this angle at the top now has been bisected, cut right in the middle. So this little angle right here is 30, and that one's 30, giving us a total of 60 again. But I'm more curious about just this small highlighted one. So that's 30 degrees. So this is a 30, 60, 90 triangle. Didn't mean to make that line in there. All right. So that's one way we could attack it then is with 30, 60, 90s if we remember the ratio of these sides. Okay. So I'm going to do that way first. This is the easy way to do it. The easy way to do it is to memorize, and this is actually on your formula sheet, I believe, that in 30, 60, 90 triangles, the sides are in the ratio of x to 2x to x root 3. And so this triangle right up here is the same essentially as this triangle in yellow. There's my 60, there's my 30, there's my right. And so these are in proportion to each other. Okay. And so I can see if this is x, this is 2x. And in fact, if this is the whole base is 208, then this little section right here, I'll highlight it in blue. This right here is 104. Half of that. And this other side is 104. But I'm more curious about this one. This is 104. This is two 104s, 208. That's x and 2x. X is 104. 2 times 104 is 208. And if my x is 104, that's my x right here. X is 104. That's my k. So k is 104. So that'd be way one. You can kind of figure it out. K equals 104. Way number two is the old Pythagorean theorem. A squared plus b squared equals c squared. And you could use your two legs. Your legs are 104 and 208. Oops. Your legs are not 104 and 208, Mr. Judd. Your legs are 104 and k root 3 right here. Hypotenuse is 208. Equals 208 quantity squared. This looks like it'd be a way tougher way to do it. Let's see here. So, k squared. So I would, man. Yeah, I don't think I'd want to go down this route. I'm going to just because I want to see how it ends up. You could certainly turn this thing off now if you'd like to. So what I've done here is I've squared my k, which is k squared, and I squared root 3, which is just 3. So that's 3k squared right there. I still have to square my 208, and I have to subtract this 104 squared from the other side. So I'm going to figure out what that stuff is right there. So I got my calculator here. I'm going to take 208 squared, and I'm going to subtract 104 squared. There we go. That gives me 3,000. So k squared, or 3k squared, equals 32,448. I'll divide that by 3. So I'll go 32448 divided by 3. Tells me that k squared is equal to 1,816. And then I will square root both sides to find out what k is. So go to my calculator here. Now let's get, what the heck is the square root of 10816? Holy cow, k is 104. Yeah, I think I'd much rather do it with proportions. And that is it for your SAT review.